Dear students, I welcome you all for today's CAD CAM class. In today's class, I am going to explain about the geometric models. Okay, so today I am going to explain about the geometric models. So in during the modeling, during the geometric modeling, okay, to represent the various parts drawings, we can represent those different models, okay, different elements drawings, by either by two-dimensional or by using the three-dimensional models. Okay, so we can represent them by according to our requirement, maybe in a two-dimensional mode or maybe in three-dimensional mode. Okay, so if you are modeling in three-dimensional models, okay, if you are modeling in three-dimensional mode or if you are modeling three-dimensional models, then we can represent these 3D models by using a line model. Okay, we can represent 3D models either by line model. So this is also known as the wireframe modeling, and we can represent the 3D model by using the surface model. So we can represent surface model by representing different types of surfaces, and we can represent a 3D model. And another one is we can represent a 3D model by using a solid. So it is also known as a solid model. Also it is known as the volume model. So we can represent three-dimensional models by using three different ways. They are line model or wireframe model, surface model, and other one is the solid or volume model. Okay, so this is one of the example. You can see that we can represent the how we can represent a like this particular line model. So I already mentioned that 3D modeling can be done by using the line modeling method or surface modeling, or by using the solid modeling or volume model. Okay, so in the line modeling, okay, mainly you can see that to the line modeling, it is also known as the wireframe modeling. So where the 3D object can be represented using the lines and curves. Okay, the 3D model in a line model can represent by using the lines. We can use only lines and curves. Okay, so mainly it shows the skeleton or framework of the object. So this type of line modeling or wireframe modeling only shows the skeleton or how the framework of the object. Okay, mainly what coming to its features, this particular line model didn't have any surface or volume information. Okay, this particular line model don't have any surface or volume information. Okay, that is its main feature. Mainly this particular line model is mainly used basic visualization, or for CNC toolpath generation. This type of line modeling or wireframe modeling is used. You can see that here this particular object is represented by using the different number of lines. You can see this okay, here represented by we can use the different points, and these points are connected by different lines. You can see that here the different number are total some uh, 12 different points are used. So and we connected all these points, and we develop different lines, and we develop this particular 3D model. So such type of thing is known as the line model or wireframe model. Main feature of this particular is because it don't have any surface or volume information. It's mainly used for basic visualization purposes, or is mainly used for toolpath generation. Okay, and second one is the surface model. So in surface model, mainly we can build the 3D model, okay, by adding the surfaces. Okay, can add by adding the different surface. You can see the same object here in the second thing we are representing it by the, so by using the 8 different surfaces. You can see this is the one surface, this is the one surface, this is the one surface, this is the one surface. Like that we are using different surfaces, 8 different surfaces we used to represent this type of 3D shape. Then such type of model will call it as surface modeling. Okay, main this particular surface model represents the object's outer shape. Mainly to want to represent any outer shape of any model, then without any thickness or without any internal volume, then we can prefer this type of surface modeling. Whenever you want to represent any objects or any like shape, outer shape you want to represent without any thickness or internal volume, then you can use this type of surface modeling technique. Okay, mainly coming to the uses, this particular surface modeling mainly used in automobile, aerospace, and different consumer products. You can use this type of surface modeling. So coming to the next type of modeling, that is the solid or volume modeling. You can see that the same model here we use the different points and lines and we connected the different lines and we developed the this 3D model. Here in the second one we use the different number of surfaces to represent this 3D model. And coming to the solid or volume model, we are going to represent this shape by using the, we can this two different volumes. You can see that we use this volume 1 and this we are use here another volume 2. So by adding these two volumes we are representing this particular 3D shape. So mainly in the volume model is a like representing both the, like we are surfacing the entire shape. Okay, outer shape we are specifying and also we are giving some internal volume also in the volume modeling or solid modeling. Mainly this particular solid model or volume model mainly contains all the geometric and physical properties. Here okay, it may can specify the mass, volume, center of gravity, all these geometric and physical properties we can specify because we are using the solid model. Okay, and this particular type of volume model we can use in your finite element analysis or CFD and manufacturing and 3D different applications. We can use this particular no, volume model. Okay, that is about the how we can represent a 3D model based on our different requirements. Okay, so the, okay, to represent these three-dimensional objects, okay, three-dimensional views. Okay, sorry, we can represent the three-dimensional views by using these no features. Like in these different features will be available in different CAD softwares. Like we can use the extrusion, that is linear extrusion, or we can use the translational sweep, or we can use the rotational sweep. By using these features we can develop the 3D models by using the 2D surfaces or 2D different 2D like two-dimensional different views. We can use that by using these different features we can convert into the 3D model. Like we can convert it into a 3D model by using a linear extrusion or translation sweep or rotational sweep. Okay, so this is the how we can see that in extrusion we can this can see that. So here there is a one 2D model we developed. Then we can use the extrusion or linear extrusion that will be available in the most of the CAD software there by by selecting the first we have to develop the two-dimensional model. Okay, over that after that we have to select the extrusion or linear extrusion option in the solid works, or maybe a CAD software, whatever thing you are using. After that, you have to select the required that particular 2D particular surface, and after that you have to specify the thickness. Then you can develop a 3D model by using this particular extrusion or a linear extrusion. Here also you can see that this particular shape sketch, two-dimensional sketch I have to develop first as per the dimensions, and after that by using the extrusion option we can specify the thickness, and we can develop a 3D model by using this extrusion option that will be available in almost all the CAD softwares. And also one of the other option is we can even perform a sweep or translation sweep to develop the three-dimensional model. Here you can see that I want to develop this type of object, a three-dimensional model. For that, first here you can see the cross section is circular one, and here the cross sectional section of this particular end is the hexagon. So we have to develop those cross section here, and after that to have that solid translation sweep, we have to connect this cross section 1 with the cross section 2, and after that in we have to you select the CAD. In the CAD software we have to select the translation sweep option. By that it will sweep entire this solid object from the this cross section 1 to cross section 2. Then that particular option comes under the translation sweep. Here also say same thing, you can see that we are developing the first cross section 1 and cross section 2, and after that we have to guide the sweep. That's why we are, as per the requirement, you have to develop there should be, you have to use the guide for curve that should connect the cross section 1 and cross section 2 in such a way that it can develop the sweep translation sweep. And the final another important feature in the to develop a 3D model is a rotational sweep. Whenever you want to perform some 3D modeling related to the symmetrical object, then you have to, you can use this particular rotational sweep. For example, you can see that this is the final model that is developed by using the rotational sweep. To develop this 3D model, we have to uh, develop the this by using this line and this particular curve. We will develop the sketch, two-dimensional sketch. After that we'll select the axis of revolution. So before that axis of revolution selection, we have to select the sweep option in the CAD software. After the once you select the sweep option in the CAD software, then we have to select the generate whatever the two-dimensional sketch you generated, and select that sketch, and after that you select the axis of revolution. Then the you can develop the three the entire this volume will be swept along the 360 degrees. It will be, the volume will be swept, and it will develop the three-dimensional model by using the rotational sweep. Like that we can use these different options to develop a CAD model that should be represented in three-dimensional view. Like this you can use different options, and we can develop a different types of three-dimensional views by using the different CAD softwares. Hope you understand about this particular topic. Thank you for listening to my class.